Okay, anybody from 1? 1A. Any more from question 1? Okay, question 2, whole thing. Next. Question 4, anybody? 4A only. Question 5? Yeah, I circled the whole tree already lah. Question 5. Anybody? No. Question 6B. 7, anybody? 8. 9A. 10? None, huh? 10 part 2. Okay. Alright, let's resume. Here, simplify. We would like to do as many cancellations as we can to simplify, right? When you have a fraction. Whatever is the common factor, we just cancel wherever possible. Okay, so let's begin. Here we have, in the numerator, 5a squared to the power of 3. What does this give us when you expand it out? This is 5 cube a power 6. Do you have that first? Are you okay with this? Or is there already a mistake made? Do you know why is it wrong now? Okay, next, let us consider the next one. 2b squared power 4. What does this expand out to give us? 2 power 4, b power 8. Okay, you must have all these at your fingertips, because it's sec. Lower sec, we already talked about them before. No, lower sec already have. Okay, next one. What does this give us? 9 squared c to the power 6. Okay, good. Then let's talk about the denominator. What does this give us? 9 squared a squared. Then this one? 25b4. Okay, no change. And this one? Okay. Then let's put everything together. So this gives us 5 cubed. Then you can choose to put all the numbers together, right? Then all the letters at the back. So we've got 5 cubed, got 2 to the power 4, we've got 9 squared, a power 6, b power 8, c to the power 6. Power 6, b. Okay, this is our new numerator. Why cannot? 2 times 3 times 4 equals to 4 times 2 times 3, right? So same reason. Everything has a reason. And you are all equipped with that skills. So please do not go away memorizing, oh, this one is the same as this one. I can do this without knowing why. There is always a reason. In the denominator, I've got 25. I've got 9 squared. Okay, we put brackets over here. 25, we've got 9 squared, and we've got 4 squared. Then we've got a squared, b4, and c power 4. A lot of time to cancel. Okay, what can be cancelled first? Okay. 25 and 5 cubed can cancel or not? So what is left in the numerator or denominator? Numerator left with 5. Because 25 square is 5 square. So there are 3 5s multiplied together in the top, 2 5s in the bottom. Cancel, cancel, left only 1 lah. Okay, now 9 square and 9 square obviously cancel. 4, oh yeah, what did I write? Oh, careless mistake over here. This is 4 to the power 4. Okay, then next. 2 to the power 4, 4 power 4. Can I simplify? Okay, what is left? In the numerator or denominator? What is left? In the numerator or denominator? Denominator, because it's bigger, right? Okay, so what is left in a denominator? 2 power 4. You're right. Okay, so far with the numbers. So 2 to the power 4, from your calculator, what does that give you? 16. So it's simply 5 over 16. All these numbers over here all became 5 over 16. Okay? Now, let's deal with the letters right now. A to the power 6 divided by a squared. What do we have left? If you can remember the formula, it looks like this. A to the power m over a to the power n equals to a m minus n. Okay? But it is one thing to memorize, it is another thing to understand. Have you all memorized it? Yes, if you have, good for you. If you haven't, do you understand why? Understand why? There. See, in this case, I've got a to the power 6 divided by a to the power 2, right? So what this means is that I got a, 2, 3, 4, 5, 6 divided by a times a. Then cancel lah. Cancel, 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 cancel. Left how many? Equals to a to the power 4. Hey, where did the 4 come from? It was 6 minus 2. Am I right? Now that's the reason why that formula exists. So here we get 5 over 16, a to the power 4. What about b? B to the power what? C to the power 2. That's it. Difficult? No, not difficult. This question, usually 1 or 2 marks for you to get the full marks. Next, part B. Cube root of 125 is the same as 125 to the power of, is it 3? Negative, are you sure? 1 over 3, yes. This is 1 over 3. Okay. Next, we have multiplied by 9 squared to the power of 1 over 4. Okay. Some things we can use our calculator to find out. For example, 125 to the power of 1/3, what is that? Cube root of 125. If you don't know, use your calculator. 5. Okay, multiplied by 9 squared to the power of 1/4. How much is 9 squared to the power of 1/4? What is squared to the power of 1/4? See this 2 over here? Can multiply, right? 2 times 1/4 is half. 9 to the power of half is 3 lah. Square root of 9, which is 3, which is 15. So, as a recap, we have I'll state down some of the laws over here. A to the power m times a to the power n, a power m plus n. Am over an is a power m minus n, a power m power n, a power mn. A to the power of 1 over n equals to the nth root of a. A to the power of m over n equals to a power m with a nth root, or nth root of a power m. Okay, then any more that I missed out? Oh yes, the negative. A to the power of negative n equals to 1 over a power n. And then there are a few more which are special. A to the power of 0 equals to 1. So this is the summary of our indices. Okay. Go and watch the video. I don't have time to let you copy all these things now. Then in your textbook also. Simplify giving your answer in positive index form. Positive index form is a phrase that is going to be seen in our O levels. So you must understand what it means. Can we have negative powers? Cannot. Do you know how to change from negative powers to positive? Yes, there is one over here. This one. A power negative n equals to 1 over a power n. So I change from negative to positive. Okay. So this is 2a power half. Nothing to change over here. Denominator. I've got 2 to the power 2 over 3a power 1/3 to the power of negative half. Okay, let's do them step by step. Negative power. I want to change it to positive. So this becomes 1 over the entire thing. 2 over 3a power 1/3 to the power of 2. Agree? Then this is the one big fraction. I've got a fraction inside another fraction. Okay so far? So far okay? Now next. Not times. Equals. Something divided by a fraction. Do you know how to change that to multiplication? Yes, you do. So for example, a divided by 3 over 2 equals to a times 2 over 3, isn't it? I'm sure you all know this. Okay, so this is actually the same as 2a to the power half divided by 1 over 2 over 3a power 1/3 to the power of 2. Agree? This fraction over here is now over here. 2a power half divided by this whole thing. Get it? No?
No, that one I said
This one?
that
This one? This one? This one? Then, see 2 over 3a power 1/3 power half, right? We learn how to change negative power. Where is it? Oh, I erased it. Did you erase it? Yeah, I erased it. 1 over 1 over a to the power n equals to a power negative n. This one. So do you get this part already? No, don't get it. You must say no.
Wait.
The highlighted parts are the same, From negative power, I put a 1 over the whole thing. To get this, power become positive.
So you put the negative 2 to
Negative 2 becomes 2 over here. About 1 over.
oh.
Okay? I need to move on already, Next. This is equals to 2a power half multiplied by, when I divide by this, I change it to multiplication, I flip it. Multiplied by 2 over 3a power 1/3 to the power of 2. Okay? So expand the one on the right, so we have 2a power half multiplied by 2 square, which is 4, divided by 3 square, which is 9. A power 1/3 square is a power 2 over 3. This step okay? Next, 2 times 4 is 8 divided by 9. A to the power of half minus 2 over 3. I'm grouping all the numbers together, I'm grouping all the unknowns together. Because a power half is in a numerator. This is the same as 2a over 1. Can? Okay, so my final answer will be 8 over 9.
Wait, what's only 1 over 2 minus 2?
So let me rewrite this. 2a power half is 2a power half over 1. Right? So when you multiply them together, I can combine. Becomes this one times this one, and then 1 times this.
So the 2 or 3?
Huh? Okay, so this becomes 8a power half divided by 9a power 2 over 3. 8 over 9, a power half minus 2 over 3, which is 8 over 9, a to the power half minus 2 over 3 is? Huh? 3 over 6 minus over 6, 4. Negative 1 over 6. Is this the final answer? Cannot be, because this is negative indices. So I need to change it to positive. 8 over 9, a power 1 over 6. Alright? Okay, part B. Can I move faster? I need to lah. If you cannot catch up, then it means you have a lot of revision you have to be doing already. K square n power 1, n power 3, power half. Let's do it straight away. What is in my numerator? K power? Mental sums, come on. 1, don't need right. M power? N power? We got negative 1. 3 over 2. Okay, now, denominator. Km cube, nothing to change. Oh, but I can expand it out actually. K cube, m cube. Now, divided by n square power negative 2. A few options you can do. Let's leave it as divide. Now, n square power negative 2. How much is that? So, n power negative 4. Alright? Okay, hang on first. So, continue. We get k m power negative half and 3 over 2 divided by k cube m cube n power 4. Agree? Do you know how I change the divide n power negative 4 into n power 4? I skip one step. I hope you can see it. N power negative 4 is the same as 1 over n power 4. Right? So divide by 1 over n power 4 is the same as times n power 4. Understand? Yeah. Stroke eraser. Okay. 1 divided by a to the power of negative n equals to 1 divided by a to the power of n with a 1 over. Am I right? Okay, let's rewrite this. 1 over a power n. Yes? Yeah. Okay. This one equals to 1 multiplied by a power n over 1, which is a power n. Get it? Same logic. Divide by n power negative 4 is the same as times n power 4. I flip already. N power negative 4 is 1 over n power 4. Yes. Okay. Next. Are you sure? Recording. Now, we are left with k to the power of. Now I want to combine already. K power. Is it k square? Negative? Negative 2. K power negative 2. Can see why is k power negative 2? 1 minus 3. Okay, now m to the power of?
Negative 2.
Look at negative 2.
Negative half.
Negative half minus 3. Okay, how much is that? 6, 7. Negative 7 over 2, yes?
Yeah.
Negative 7 over 2. Now n to the power of? 3 over 2 minus 4. 3 over 2 minus 8 over... negative 5 over 2. Okay, now everything is in negative indices. I need to make them all positive again. So I get 1 over k square times 1 over m power 7 over 2 times 1 over n power 5 over 2. So don't need write all the times. It's actually the same as 1 over k square m 7 over 2 and 5 over 2. This is our final answer. I'm not checking with the answer key at the bottom. There's the answer key given?
Yeah.
Yeah, okay, so help me check. Question 3, part 1. Find the following without using a calculator. What is 8 to the power of 2 over 3? How do you get 12? No, you're not supposed to use the calculator. Numbers such as these: 2, 4, 8, 16, 32, 64, 1, 2, 8, 2, 5, 6. What's next? 5, 1, 2. Do they sound familiar to you? Why? How are these numbers related? Same.
2 to the power of 4 to the power of 5.
2 to the power of something, is it?
Yeah.
Have you do you find these numbers familiar anyway? Besides talking about maths, we don't talk about maths. Do they sound familiar to you? Yes. When? Where have you seen it? Where? What? No, I'm not talking about maths. Don't the numbers sound familiar? No. Yes. Where? When do you see them? Okay, I highlight some of the more common ones. Still not familiar?
Oh.
No, I'm telling you it's not maths. Something you all have in your bags and pocket right now. No, not money. Pocket and nothing, then in your bag lah. Sure have one. What? Handphone? Do you see these numbers?
Where?
Hey, your buy phone don't care about the specifications on it. What space? There's the RAM, there's the memory.
Gigabyte.
What?
2 gigs.
So, yes, right, we see them in our phones. Why do they use these numbers? Why do they want to use these numbers? Huh?
No, more.
No. Yes. Okay, so 8. You need to know 8 is actually 2 to the power of? Yes, 2 to the power of 3. Then we've got 8 to the power of 2 thirds, right? Okay, next. 4 is actually 2 to the power of 2. Then we divide by 256. 256 is 2 to the power of 2 to the power of 8. Then to the power of 1 over 4. And let's continue to simplify. 2 to the power of 3 to the power of 2 thirds. What is that? What do we simplify this to become? 2. Okay, so this is 2 to the power of 2 times 2 to the power of 2 divided by 2 to the power of 2. Yeah, then it's 2 to the power of 2 lah, which is 4. No need calculator lah. You can key in this whole bunch in, you'll get answer 4. What do you mean minus? You mean this part? Yeah, this part 2 to the power of 2 divided by 2 to the power of 2 is actually? Okay, moving on. 1 over 49. You need to be aware what is so special about the number 49. What do we have? What square? 7 square. Negative 1.5, which is negative 3 over 2. Okay, so this is the same as 7 to the power of 2 to the power of 3 over 2. Can do all the flipping in your mind? And this gives us 7 to the power of 3, which is 49 times 7. For this step, 49 times 7, you want to use your calculator, you can use that. 49 times 7, 3, 6, 28, 34. 3, 4, 3. Can? You always wait till I go past already, then you ask question. One over 7 square to the power of -1 to the power of 3 over 2. So 1 over 7 square to the power of -1 is 7 square. I flip. This one, just flip. Next. Simplify this. Looks very tedious. X to the power of 1 over 2. Y to the power of -1. Are you able to do this? Just times, yeah, that's it. Then the division divided by x to the power of cancel 2, 3. -1 over 3, is that it? 1 over 6, oh yes, it's -1 over 6. Then we've got y to the power of negative again, 4 and 4, 3 over 10. Multiplied by x to the power of -1/3, y to the power of half. Okay, I hope I didn't make any careless mistake. You got so many pairs of eyes helping me to check. Next, this is x to the power of half, y power -1. Since there is a division, then flip the sign to become positive. Multiply by x to the power of positive 1/6, y to the power of 3 over 10 times x to the power of -1/3, y to the power of half. So group all the x together. X to the power of half plus 1 over 6 minus 1 over 3, y to the power of -1 plus 3 over 10 plus half. Get the answer. X to the power of something, y to the power of something. You gotta figure it out. What? Okay, next. Question 5, not needed. Question 6. How long? Sure, no, this question. What's the thickness of one coin? Okay, then. So? Okay, what's your point? Why shouldn't ask?